The next example is going to be much more interesting. We're going to use a linked list. So given a pointer to the head node of a linked list, the task is to reverse the linked list. We need to reverse the list by changing links between nodes. So let me explain how a linked list works. So in a linked list, we have nodes, and that nodes are connected with a pointer. The pointer is pointing to our next node, and that node carries some data. This could be a JSON object, it could be an integer, it could be a string, whatever. When we want to navigate through our list, we have a head which always points to the first node here, and that head has an object next, and the next object is this pointer that points to the next node, and each node has that information. So each node has the information about itself and the next node, and this node again has information about itself and the next node, and so on and so forth. So what we need to do is, while traversing that list, while going forward, to reverse that effect. So to reverse it, to look backward. So let's say we are at this position and we are looking at the next node, and this is our next node. So we transition to the next node. But now this node has a next node which points here. So what we need to do is move the next node of this one to be actually here and not here. So we are going to delete this here and move it to be in that direction. But we still need to remember this in order to be able to jump to that node. When we jump to that node, we are again going to use that information to point here and delete that one, and so on and so forth, till the head actually comes to our last element. Let us do that. First of all, let's create a class and use some space here. Let's create a class called node. In that class, we're going to have our init function, which is going to have self and data. So as we have mentioned, there is some data for our node. We're going to initialize our data to data, and we're going to have the next node that we have just shown here. It's going to be none. So the node is in standalone mode. It doesn't know where it belongs. Now we are going to have a class linked list, which is again going to have an init function, passing the argument self, and we're going to have self head be equal to none. So the head, the first element that we have also drawn in the graph earlier. So let us define the functions that we need. Let's define our reverse function, taking in self, and I'm just going to print reverse as of now. Let us create some other functions that we need for our linked list, like push and print, so that we can add elements to our list and that we can print our list. So define push self and new data, some data that is going to be pushed to our list. New node is going to be equal to node with that new data. So we have just created an instance of our class node here with our new data here. New node next is equal to our head, and our head is going, so our self head is going to be equal to our new node. So let me show what I have done here. We are adding a new node, so that new node just exists here, and we have a head which is pointing to the first node here. So what we are doing is we are pointing the next to point to our current head, and we are going to change our current head to point to our new node that we have added here. So as you can see, we are adding elements at the beginning of the list. We could also add it at the end. In order to add it to the end, we would need to traverse that list, and then at the last element add a next element, which would go here. Or we could also keep track of the last element, so we don't need to traverse the entire list every time. But in this case, we're going to add the elements at the beginning of the list. Now we also need something to print this. So print list. And what we're going to do is create a temp object here, which is pointing to the head. We don't want to change the head. We don't want to mess with that. But while we have a temp object, so while it is pointing at something and not empty, we are going to print our temp data. So our data that we have there. So our temp is pointing at the head, and the head is a node, and that node has data. So we are going to print the data, and then we are going to go to the next one. And if there is no next one, so if this is going to point into nowhere, then this is not going to be true, and we're going to exit our function here. So let us create a list. So list is going to be equal linked list, and now we can push some values. So let's push 1. Let me copy that a few times. So let's give it a 10, 5, 4, 6, and 8. And let's call list print list. Let us run this. Python. So we have printed our list. Since we are adding at the beginning, it's 8, 6, 4, 5, 10, and 1. Okay, great. So now we need to reverse it. Let's create our reverse function. So how are we going to do that? First of all, we need a previous node. So this is going to be initialized with none. Then we need a current node, and the current node is going to start with the head. Now we're going to have a while loop. While we are going to check that current is not none. So here we were checking if it has something, and here we have rewritten it as if it's not none. If it's not none. And now we need to have a next one. Since we're going to destroy the next element, we need to keep somehow track of it. So current next. What I mean by destroy is let's say we are at this position here, and we have our next, which is here. But we are going to destroy this link, and we need to keep somehow track of it so that we can actually jump to the next one. And before we reverse it so that we can jump to the next node. So that's what our next here is for. Now, our current next is going to be equal to the previous one. And the previous one is going to be equal to the current node. And the current node is going to be equal to the next node. And when we are ready with this, our head is going to be equal to previous. Let us rewrite that one more time, or actually just going to move here. Okay, so we have a node here, we have a node here, and we have a node here. So the first thing we do is we mark the next. So we mark that our next is actually here. Now, let's say, to make it simpler, that we are already somewhere here. So what we are doing here at this position is marking our next as a previous one. Since we have the value of the previous as prev, we are going to mark the next one of that node to be the previous one. So to be this node, and this here is destroyed. And now the previous becomes the current. Since we don't need this anymore, this is already connected. We move the previous to be here now. And we move the current to be the next one. So the current, so we are just moving like steps like that forward. Let us check if this is going to work. So list reverse and list print list. So let's run this. Maybe I should have printed some. And let's see. So 8645110 110548. Yay! We have managed to reverse our linked list. So I hope this example was quite fun to you, because this was something more like real life coding, something you would probably implement somewhere. Maybe not really creating a linked list, but working with pointers or traversing something or doing some operations on lists. So I hope you had fun with this example, and let's continue to the next one.